Okay, guys. Okay, so let's get started without any further ado. In our session today, we'll be taking up the first class of the Certified Ethical Hacking course. As discussed in the earlier session, today we'll be starting with one of the most important three requisites called networking fundamentals. Okay, so this again is where we basically discuss what networking is, what are IP addresses, and what are some important protocols in networking that we usually come across in our day-to-day lives when working in cybersecurity. Okay, so in talk about networking, this is basically the concept of connecting information systems with each other in an organization. So again, in organizations, you have multiple sorts of devices. You have routers, switches, printers, IP cameras, desktop workstations, servers, IDS, IPS systems, whatnot. So networking is the practice of connecting all of these different sorts of information devices with each other so that they can share in resources or data. Okay. And that collective group of all of those devices together is called as a network. So network is a collection of all those interconnected devices that can communicate with each other. And every individual device or every individual system in that network is referred to as a host. So as mentioned again, computers, printers, routers, mobile phones, IP cameras, smartwatches, whatnot. Each of these devices which is connected to that network, which can communicate with another device, transmit or receive data is called as a host. And just like how we have our names respectively to address each other, these devices also have their own names. And that naming convention is called as IP addressing. So IP stands for Internet Protocol Address. And again, when this was built by the US military, there were multiple versions of it. There were experimental versions like IPv1, 2, 3. They were quite experimental. They didn't work out properly. What successfully panned out was IPv4, Internet Protocol version 4. And we're still using IPv4 addresses in today's world. Okay. To define an IP address, each host on the network has a unique identifier, and that unique identifier is known as an IP address. It allows for communication to occur between the devices. Okay. Now, your IPv4 addresses have some important properties to them. Firstly, it's a 32-bit address. What I mean by 32-bit is that it contains 32 zeros and ones. A bit is the smallest value a computer can hold. So it is either the value 0 or the value 1. Okay. And your computer, your IP address has 32 zeros and ones as such. And this entire 32-bit address again is divided in four equal parts, where each portion contains 8 bits, and each of that 8-bit portion is known as an octet. And each octet again is separated by a dot symbol. So here you see we have 8 bits, then there's a dot, then another 8 bits, then a dot, then another 8 bits, then a dot, and then another 8 bits. And that way we have the entire 32-bit address here. Now, what we see here in the language of zeros and ones is called the binary language, okay, because it only contains two characters, zeros and ones. And computers understand this language very well, but we humans don't understand it so much. What we actually use or regularly come across are decimal numbers, numbers from 0 to 9. So this number 11000000 is actually equal to 192. This number 10101000 is actually equal to 168. This number with all zeros is simply 0. And this number 00001010 is actually 10. But how am I giving you this conversion? How do you convert a binary number to a human readable decimal number? Let's talk about that. Okay, so to convert a binary number to a human readable decimal number, there are two simple steps. So let's say we take this number here, 10101010. So if I have to convert this number to a human readable decimal number, firstly, I have to write down the values of 2 power 0 all the way up to 2 power 7 from right to left. So under the rightmost bit, we have 2 power 0, then 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left, under each bit, you're assigning these values. If you ask me why specifically 2 power everything, because it's a binary number. There are only two possibilities, therefore 2 power everything. And now, once you have these values written down, you need to multiply the lower value with the top bit and add it to the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So irrespective of what bit you have on the top, you just multiply the lower value with the top bit and you add till the end. And that gives you the final decimal value. So to perform this calculation, we need to know these values first. Anything to the power of 0 is equal to 1. It's a mathematical rule. So 2 power 0 is also 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is similarly 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Now that we have these values here, we can substitute them here and get the final answer. So 2 power 0 into 0. 2 power 0 is 1, so 1 into 0, that's 0. Plus 2 power 1 into 1, that's 2. 2 power 2 into 0, again 0. 2 power 3 into 1, 2 power 3 is 8, so 8 into 1 is simply 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. And if you add all this up, 128 plus 32 plus 8 plus 2, you get the number 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. It's something like high frequency, high, low, high, low, high, low. When that exact sequence of the frequencies flows through a computer, it understands it as this number 170. Okay. So that's how you convert a binary number into a human readable decimal number. Okay. Is that clear? Any questions or doubts up to this point? Imran, Velma. Okay, assuming this is clear. Moving on. Now, the reason I'm explaining you all this is so that we can get the complete range of IP addresses. So now, if I have to get the first IP, all I have to do is put zeros everywhere in every octet. So for example, if I have to get the first IP, in the first octet, I'm going to put all zeros. In the second octet, I'm going to put all zeros. In the third octet, I'll put all zeros. And in the fourth octet as well, I'll assign or put all zeros. And when you convert that from binary to decimal, you get the first IP as 0, 0, 0, 0. And when I put all ones, okay, so if I put all ones, the value would be 255. So 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1, everywhere into 1. So that would be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that would give you the number 255. Okay. So if you put all ones, the last IP you get is 255.255.255.255. Okay. So again, from this binary to decimal conversion, we can understand easily the range of the IP addresses, what the first IP is and what the last IP is. So your IPv4 addresses will never progress beyond the number 255, whatever IPs you have. In every octet, the number will only range between 0 and 255. Okay. And we have to calculate how many IPs are there in total from the first IP till the last IP. Each bit here has two possibilities, zeros or ones, and there are 32 bits in total. So 2 to the power of 32 will give you approximately 4.3 billion IP addresses. So when these IPs were invented also in the late 1950s, they thought 4.3 billion IPs is a very large number. But fast forward, oh, is my screen not visible? Why is it 1 second? How about now? Imran?
Yes, sir. I can now see your screen.
Okay. So yeah, again, as mentioned, when these IP addresses were invented in the 1950s or so, they thought 4.3 billion IPs is a very large number. Because back then you didn't have any mobile phones, you didn't have many people accessing the internet in the first place. But fast forward to 2025, the population itself is almost 9 billion people. And again, if you talk about each person, they have multiple devices. So 4.3 billion IP is assigned to each unique system would never have sufficed. Okay. So that is why these IP addresses are again divided into various categories. There's something called as classes. There's something called as public and private IPs. We'll cover all that. But before we dive into that, let's talk about the sequence of IPs. Now we know this is the first IP and we know this is the last IP. But about the IPs in between? How are these IPs progressing one after the other? So to understand the sequence again, there are two simple rules. Rule number one, always start incrementing from the rightmost octet. So always increase the value of the rightmost octet first. So if you have the first IP as 0000, next IP would be 0001. Okay, so the rightmost octet increments by 1. Then 0002, then 0003, then 0004. This goes all the way up to 000, 254, 255. Okay. Once it reaches the maximum value here, 255, it cannot go beyond that. It can't go to a value like 256. Okay. So then comes rule number 2. Once the rightmost octet reaches the maximum value, then you move to the left octet. So this 255 cycles back to 0. It resets back to 0. And the left octet, the one right next to it, increments by 1. So after 000255, you have 0010. Now after 0010, don't directly jump to 0020. Remember rule number 1, always start incrementing from the rightmost octet. So then you have 11, 12, 13, 14, which goes up to 1255. Okay. Now after 1255, the 255 cycles back to 0 again, and this 1 changes to 2. So then you have 2021, 2223, which goes up to 2255. Then 3031, 3233, which goes up to 3255. 40414243, which goes up to 4255. So the cycle keeps on repeating, and somewhere down the line you would have 2550, 2551, 2552, 2553, which goes up to 255, 255. Now both these octets are filled. What happens then? You reset both of them back to zeros, and the next octet changes to 1. Okay, so then you have 100. So now whatever pattern repeated from 000 to 0255255, same pattern again repeats from 100 to 1255255. Okay, so 0001, 0203 goes up to 0255, 10111213, which goes up to 1255. So the same pattern which has repeated all the while from 000 to 0255255, same thing repeats from 100 to 1255255. 200 to 2255255, 300 3255255. Similarly, down the line, 25500 to 255255255. Okay. Now, whatever pattern has repeated from 0000 to 0255255255, this entire pattern again repeats from 1000 to 125525525, 2000 2255255255, 3000 to 3255255255, and down the line 255000, 255, 255, 255. If you count each and every single IP, the ones which I've skipped as well, then you'll have a total of 4.3 billion IP addresses. Okay. So that is how we talk about the sequence of IP addresses. I know a bit confusing for the first time, but again, if you just go through this recording again, it might get a bit more clear as well. But for now, any questions also? Shall I repeat this sequence one more time if it's a bit unclear? Any questions? Imran, Velma,
Yeah,
Andy.
it's okay, sir.
Okay, perfect. Moving on. So as mentioned earlier, this entire 4.3 billion IP address range is again divided in various categories. There's something called as classes, class A, B, C, D, and E. And again, each class is subcategorized in two parts. There's something called as public IPs and private IPs. So class A has public and private IPs. Class B also has public and private IPs. Class C also has public and private IPs. Class D and class E are exceptions. They don't have any private IPs in them. All of them are public IPs itself. Okay. So before we dive into the classes in the upcoming sessions, let's discuss what public and private IPs are today. Okay. So to understand the concept of public and private IPs, we can just take the example of our own home network simply. So now at our home, we have a Wi-Fi router, and to that Wi-Fi router, we have all these other devices connected wirelessly. Your laptops, your smartphone, your smartwatches, your computers, whatnot. Okay. So now All of these devices belong to your own local network. And this local own private network is also commonly known as the intranet. Okay. So when any of these devices have to communicate with each other, they'll always use something called private IPs. Okay. So private IP addresses are the IPs used in a local network for all your intranet devices to communicate with each other. Okay. So when your phone has to communicate with the router, or when your laptop needs to communicate with another desktop, you don't need a public IP for that. All of these are your local network private devices. Okay, so these require private IPs. If you notice here, every device is getting a unique IP. Your router is getting something like 192.168.0.1. Your laptop is getting 192.168.0.2. Smartwatch 0.3, smartphone 0.4, computer 0.5. Each device in your home network has a unique private IP. Okay, and these IP addresses are used by them to communicate or address each other, and again transmit data to each other. But when any of them wants to communicate with the internet, then they need something called a public IP. So your router gets a cable from outside your house. It's called again, it's basically an RJ45 cable or an optical fiber cable. It is again attached to your router from the closest hub outside your house. So when you take the internet connection, the ISP guy, internet service provider guy, sets up the router, brings a cable and attaches it to the router, right? So that cable provides you the public IP, okay, from the ISP, internet service provider. And this public IP is what is used by all your devices. It's what is shared by all your devices to communicate with the internet. Okay. So when your phone wants to communicate with Google, it first sends the packet from its IP to the router's private IP. Then the router shifts the packet from the private network to the public network. That's the purpose of a router, to communicate between two different networks. Okay, so it's acting as a gateway here between two different networks, between the private network and the public network. Okay, so it can route the traffic between two different networks. So it now shifts the packet from the private IP to the public IP, and with that public IP, it reaches the internet, and it travels across different multiple servers over the internet, and then reaches the Google's server. Okay, so that is where you use public and private IPs. To define public IPs are globally unique IP addresses, which are used to identify devices or networks on the internet. They're allocated by the internet service provider, and they are routable over the internet. If you want your traffic to go across the internet, you need a public IP for that, which can only be assigned by the ISP. Okay, and again, when I say ISP, examples of such are Airtel, Act 500, Hathway in India. In US, you have ISPs like AT&T, T-Mobile, Verizon, etc., etc. Okay. So if you want to check what your public IP is, you can simply open up your browser, and in your browser you can search for what is my IP, and that shows you exact public IP as well. So if I open up, oh, just a second, yeah. If I click on these links as well, what is my IP address.com? I'm getting this public IP here. So if you notice, all the numbers here are between the numbers 0 and 255. Okay, they will never go beyond that. So this was IPv4. There's a much more latest version called IPv6 as well. We'll be covering that in the upcoming sessions. Don't worry. Okay, but for now, we are again discussing about IPv4. So this is what your public IP looks like. Okay, and if you have to check what your private IP is, IPs which are used within your private networks for local communication, you have to open up your command prompt and run ipconfig. So please note, private IPs are not directly accessible from the internet. You can't connect to the internet just with a private IP. You need a public IP for that. They only allow communication in the same local network. So if you have a network with 100 devices or so, and if they want to communicate with each other, you can just use private IPs for that. You don't need a public IP. Okay. So again, to check your private IP in a Windows device, you can open up your command prompt. And in the command prompt, you can type ipconfig. Okay, so this is how you check your private IP as well. Okay, so you can open up your run Windows R and type CMD. This is one way. Or you can just search for CMD in the Windows button. Again, it opens up the command prompt there as well. Right, excuse me. Any questions or doubts up to this point regarding what public and private IPs are? Anyone? Andy, Imran, Walima. Okay. Oh, Imran, I think your mic is unmuted, but I can't hear you for some reason.
Oh, okay. So the public IPs are publicly available all over the internet, but private IPs are only limited to the intranets. That means local networks.
Local networks,
Am I right?
exactly. Right, exactly. And
Thank you.
so in your home network and your local organization networks, okay, in your various departments, you use the private IPs for local communication. But when this traffic needs to go on the internet, you need a public IP for that. Okay, as simple as that. Okay, so public IPs are for worldwide public network. Private IPs are for your local private networks. Okay. Right. Moving on. Again, each of these public and private IPs have a range, guys. So this is what we'll be discussing in the next session. So it's important to remember these ranges. Each class has a specific range, and in that range, there's a specific range for private IPs as well. So we'll be covering what these ranges are. We'll also be covering what the necessity of each class is. Okay, so what is class A, B, C, D, and E? What's the relevance of each class? What does class C do? What does class B do? What does class A do? Okay, what are class D and class E? Okay. Then we talk about something called subnet mask. Then we talk about how do you assign a private IP. Okay. How do you assign it manually from the control panel or from a DHCP server? Then what is a DNS server? Okay, we'll be covering all this in the next session. Okay. So still again, there's a few more students who are supposed to be joining the demos. Again, they are again, I think they weren't available today. We'll just wait for one more day. Tomorrow, we're going to be covering all this extra content, guys. Okay. So since these are demo sessions, we are taking them shorter. But once we start our actual classes, they're going to be much longer than this. Okay. So I'm going to conclude the session over here. We'll wait for the others to join as well tomorrow. And then we'll resume all the remaining content. We'll complete this remaining topic. Okay. So any questions or doubts before we exit the session regarding this class or regarding cybersecurity as well, since we have time? Andy, well,
Sir, I have a question. That is, in order to understand the security as a big picture, so do we need to have good understanding about the hardware, like how the switches, routers,
no, no,
modems, and
not
all other devices?
no worry, no, not at all, not required at all. You just need to know sometimes how do you configure these firewalls. Okay, again, but that is easily no. Again, you already have a lot of content online manuals for those. But other than that, you don't require any hardware knowledge at all. Not required.
Okay, okay, right.
We just need to know how to use a lot of tools for configuring and performing these operations, pen testing operations or configuration of various devices on the network. But other than that, you don't require any physical hardware knowledge of these devices. Definitely not.
Oh, okay. Just one more thing. That is, I'm not sure whether it is applies to the router or modem. So there is a access control list that determines what internet traffic should be allowed or not. So
Right.
is it part of uh, the CEA's course configuring that access control list?
Configuring that, no, not really, because that is about us configuring again the whitelisting and blacklisting rules, and varies from
Right.
just firewall to firewall. But again, if you want me to show you, I can show it in the Windows firewall, which we have access to in our network. So it's not a part of it, but if you want me to show it, I can show that. That's not an issue.
No, no, not right now, please.
Yeah, later on, at least in the upcoming sessions when we come across the topic of firewalls, at least then I can show you that.
Okay,
Definitely.
great. Yeah,
So
thank you.
now, so again, if there's any topic that is related, again, in close relation with cybersecurity, but not included in the course, I will definitely show that. That's not an issue. You can ask me anything regarding cybersecurity. And even if it's not in the course, I'll include it and explain. That's not a big deal.
Okay. So are we going to have the classes 5 days a week, except for the Windows
5 days a week,
weekends?
from Monday to Friday for one hour sessions. Once we start the actual class, these are demos, so therefore they are a bit shorter. But once we start the actual course with all the registered students, 5 days, Monday to Friday, 5 days a week for 45 minutes and 15 minutes doubt session in the end.
Okay. So the next class will be a demo class or a regular class?
I think we have demos until this Thursday, which is, if I'm not wrong, yeah, until tomorrow. I think tomorrow would be the last demo. And after that, once we
Okay.
have a registered list of students, we'll have the actual classes. Tomorrow, if I'm not wrong, should be the last demo. Imran.
Okay. Thank you, sir. I do not have any other questions.
Yeah, okay. Andy, any questions? Velma, any questions? Yeah. Assuming no questions, we can exit the session here, guys. We'll be disconnecting here. And if you have not accessed the earlier sessions, all of these are being recorded. You can access them on YouTube. So you just have to go to your browser, search for YouTube here. And in YouTube, you can just search for cybersecurity. So we have been taking these demos from last Sunday. So you can search for cybersecurity, DURGASOFT.
Hello, am I audible?
Oh, and yeah, I can hear you.
Yeah. Actually, I'm asking about this curriculum, like the syllabus, which will cover intermediate level or how it's a beginner level.
We're going to cover the same exact syllabus of the same EC Council CEH course, Andy. So covers from the very basics up to intermediate level on performing pen testing on every endpoint. We talk about network pen testing, web application pen testing, okay, cloud pen testing, IoT as well. Okay, so basically from basic level to intermediate level. After that, you can take up a specialization in any of those individual domains. Okay, you can specialize in network security or mobile security or web security or whatever it is. So for the requirement of knowledge of penetration testing, up to 3 years of experience in this domain, you can again go through this course. Okay, and again, if you want a much better curriculum list, you can actually visit the official EC Council webpage itself. I've shown this in the last class, and those recordings are over here. If you notice, these are the recordings actually. Seminar, demo one, etc. So these were the recordings. You can access them by searching for cybersecurity DurgaSoft and filter them by recently uploaded. Yeah. And this here is the curriculum actually from the official website of EC Council. These are the modules we'll be working on. We have already completed introduction to ethical hacking. And again, we are learning some prerequisites right now. After that, we'll dive into these other advanced concepts. Is that clear, Andy?
Okay.
Sir, Imran again.
Sorry, Imran, come again.
Yeah. Yes. Sir, after completing this CEH course, so is there any other advanced course offered by DurgaSoft?
By DurgaSoft for cybersecurity, currently no, Imran, but again, I do offer them privately for the advanced courses actually. So if you're interested after this course, I specialize in web application pen testing actually. So if you're interested in that, we can connect separately after this course is done.
Okay, great.
And
Yeah, thank you, sir.
no problem. Sure. Any other questions, guys? Okay. Assuming no questions. Oh yeah, Andy, using some.
Thank you.
Thank you. Have a good day. We'll connect back tomorrow at the same time to continue from where we left off. Bye-bye.
Okay.
Uh,